Hey students, welcome to your second week of lecture. We're on Unit 6, Experimental and Quasi-Experimental Research. This will be a continuation from correlational research. Our objectives for today, we're going to be reviewing experimental research, understand why experimental research can be considered causal at times, and discussing quasi-experimental research as well. As I stated in the previous slide, we're actually going to be continuing off from correlational research and be talking about experimental and quasi-experimental research today. Experimental research is now a study in which we have one or more variables that are manipulated and the others are measured. Now we're in the realm of independent variables and dependent variables. We manipulate one of our independent variables and measure one of our dependent variables. And we'll talk about more about how we do that and how that works. Quasi-experimental is another type of experimental study. It's kind of experimental, but kind of not. So we call it it's this hybrid condition. However, it's a study in which we have one manipulated variable and the others are measured. However, the manipulated variable is a pre-existing grouping variable in which we talk about sex. And we'll discuss this more as we progress throughout the slideshow. So let's go ahead and dig right into experimental research. As I mentioned previously, an experimental study is a study in which a researcher has manipulated at least one variable and measures another. The manipulated variable is known as the independent variable, and the measured variable is known as the dependent variable. So remember, think about your independent variable as your predictor variable, and your dependent variable as your outcome variable. Now there's many types of different experimental designs. We don't have enough time to cover all of them. In fact, we're only going to be covering 3 different types of experimental designs, but they're extremely important, and if you get into the field of experimental research, I'm sure you will learn about all the different types of experimental designs that exist. And I just want to re-emphasize that we can now start using the terminology of independent variable and dependent variable, in which case we're actually trying to imply causation with experimental research. I'd first like to start this lecture by talking about some terminology that we'll be using time and time again. I think the majority of these you've actually seen before, but I think it's good that we re-emphasize them throughout this lecture. So the first one that we'll be talking about is a manipulated variable. A manipulated variable is a variable that is actually changed by the researcher. So this is something like the type of music played during a test. Will one condition experience metal music? Will the other one experience classical music? Or will there be one condition that experiences no music at all? Next is a measured variable. This is simply put a variable that is measured by the researcher. So this is some sort of outcome variable. It doesn't necessarily always have to be an outcome variable, but in the terms that we're going to be talking about today, it's usually the outcome variable, or aka the dependent variable, which I'll be discussing in just a little bit here. But it's just a variable that's been measured by the researcher. Next is the independent variable. This is our main manipulated variable of interest in the study. Keep in mind, it needs to be a manipulated variable for it to be the independent variable. The different levels created by the researcher are known as levels, and we've seen that before. We know that any variable takes on levels of some sort, but the conditions here are different levels, so these can be different conditions. They can be some sort of way of indicating that they're people that they've assigned to different conditions of the study. Next is dependent variable. This is the main measured variable of interest in the study. You can have other measured variables of interest in the study, but this is the main one, otherwise known as the outcome variable of interest. It temporally, which means time-wise, should come after the independent variable. So keep in mind that that's one interesting aspect, one main aspect of a dependent variable is that it will always come after the independent variable. So we want to look at depression at the end of some sort of manipulated therapeutic sessions where we're using cognitive behavioral therapy, music therapy, or something, but we want to measure depression at the end of the session, and that would make it a dependent variable. It wouldn't make sense to talk about it in terms of measuring depression at the beginning and then providing them the independent variable. There's no sense in that because we haven't used the independent variable to utilize a cause of the dependent variable. Lastly is a term called control variable. I don't remember if we've actually talked about this in the past. However, a control variable is a variable that a researcher holds constant in a study. So this is where a researcher will make sure that all participants in the study have the same aspect or characteristic of. One oftentimes research control variable that a researcher will utilize is something like age. They'll make sure that everyone has the same age or age range within their study. Now, the beauty of experiments is that they're actually causal. We can make causal claims because we have an experimental study. Now, I will say the amount of causal confidence you can have in your causal claim will depend on how well the experiment is designed, but their generally met purpose is to make causal claims. When we were running correlational and descriptive studies, we weren't able to make these causal claims. However, now we are able to make those causal claims. And the two reasons we are able to now start making these causal claims is because A, we always have some sort of true comparison group within an experimental study. Additionally, a researcher is able to use those control variables and control the variables that we think cause problems. For example, if we think age is a problem indicator within our study, we can just make everyone the same age or make it so that we have certain age ranges within our study so that age isn't an aspect of the study anymore that's associated with this. So we think that we clearly know that age is associated with dying or age is associated with depression at some point in your life. We can say that everyone in the study has the same age, therefore we are controlling for this. So this is really, there's a lot more reasons why experiments are causal, but these are the two main reasons that we're going to emphasize on so that we can say that we have causal claims from our independent variable leading to our dependent variable in an experimental study. Let's go ahead and start with point number one that I talked about, which is experiments have a true comparison group. Normally, in a true experimental study, there is the control group. Unlike a correlational study, although there are groups we can have comparisons with, they're not true comparison groups because they're not groups that we manipulated and made happen artificially. Those are groups that were naturally formed that we don't know the history of before of it. Therefore, correlational studies, although you can have these comparison groups, and I always emphasize in your hypothesis to have some sort of comparison group despite the study design, it's not a true comparison group like it is in an experimental research study. We oftentimes compare the control group with the treatment group to see if there's any differences between the groups. One aspect you'll normally see this is in medical research, in which we have one group that receives some sort of treatment medical pill of some sort and the other one that receives a placebo pill or no pill at all. In an experiment, you need to randomly assign your participants to different conditions. Now, there is going to be one experimental design that I talk about where we don't talk about the terms of random assignment. However, random assignment is very great in a way to help us have a causal effect, to determine a causal effect. Now, a random assignment is when the experimenter does not choose who goes into what group. That is, they randomly assign who goes into what group. Instead, they let fate decide. This is through something like a coin flip or a random number generator of some sort. I think this image on the bottom does a really good job of explaining what's going on. So we always have our population. We defined our population of interest as we learned from sampling. Then we take a sample and get a random selection from our population using some sort of sampling technique that can be a convenient sample, a simple random sample, stratified random sampling. Some sort of sampling technique was exhibited to get from our population to our sample. Then we use this idea called random assignment, where we take our sample and randomly assign them to 1, 2, 3, 4 conditions, however many conditions or groups. Conditions are the same as groups you have within your study. In the image below, they randomly assigned into a control group and a treatment group. The next aspect of experimental studies is that you can control for problem variables. By controlling for these variables, we eliminate the bias that comes from them. These variables that we're controlling for are often called confounds or confounding variables. So a confound is a variable that's related to the independent variable and the dependent variable and causes bias in your results. So for example, We can control for what type of computer screens people look at. And what that means is that everyone in the experimental study has the same exact the same exact computer screen that they're looking at. Therefore, we know that if there's any problems and associations with the computer screens, everyone's experiencing the same problems. Therefore, it's really not the problem anymore, because the computer screens are not what's causing the dependent variable at all. We can be rest assured that the independent variable is causing the dependent variable. Additionally, another thing that people often control for is who is teaching a course. So if there's a experiment where there is some sort of course involved, some sort of, let's say, an educational course on sex education or something like that, and where one course is on sex education, the other one is on a different type of sex education, and they want to compare the two groups, well, we can use who's actually teaching the course, so that we know that if we have the same teacher in both conditions, that it's not the teacher that's causing any of the problems that are associated with the dependent variable. The independent variable, the manipulated condition itself, is what's causing the dependent variable. So we can't really control for variables in correlational studies. I wanted to note you can control for these statistically, which you'll learn about in Psych 350, but you can't artificially control for them in correlational studies, which makes it a big difference and why we really could love experimental studies for this exact reason. I'm going to go ahead and just talk about internal validity again, because this is a really important aspect with experiments. Experiments have higher internal validity than correlational studies because we are able to control for variables, have this random assignment aspect to it. This is all with the key assumption that the experiment is done correctly. So arguably, experiments are the most internally valid type of study design. This is because because of this, we're able to make these causal claims by having comparison group and controlling for variables. But this is only true if you eliminate all of your confounds. Now, I want to note it's actually not really possible to eliminate all of your confounds. So we're really just trying to control for most of them and eliminating most of our confounds. So this is things like anything associated with, making sure everybody has the same exact computer screen they're looking at, or the same exact teacher is teaching whatever classes are the experimental conditions, so that we know that teachers aren't causing anything to do with the dependent variable. In this course, we'll be talking about 3 different types of experimental designs. I want us to note that there are a lot more experimental designs that exist, and additionally, many derivations of these exact same experimental designs. However, these ones exist the most within the literature, and therefore when you're reading through the literature, I think by knowing what these 3 are, you'll be able to get away with understanding a lot of it. So the first one is between group designs, then there's within group designs, then there's mixed designs, which is really just a mixing of the exact 2 beforehand and really is the ideal design to be having. The first experimental study design that we'll talk about is between group designs. Now, I'll tell you, these are pretty simple, and all you need to do is honestly look at the image below to kind of understand what's going on. So, in between subject designs, participants only experience one condition. So, let's go ahead and look at our image at the bottom line here. The square that it says participants is essentially our sample that's been pulled from our population of interest. Then, we randomly assign, which means we use some sort of random number generator or rolling of die or flipping a coin to assign participants to either a treatment or a control group. And that's pretty much it, is that we just simply got our sample and turned them into a treatment and control group. The next experimental study design that we'll talk about is within group designs, in which all participants experience all conditions of the study. And additionally, there's no random assignment associated with this, which is actually a detriment to the study design. However, one of the benefits of this is that you see how the same participants would do in all conditions of your study. So essentially, all participants serve as their own control group. So if we look at the image below, we can see how within subject design works, in which we have all of our participants that are sampled from a population of interest in our square one. We then have them go through something called a pre-treatment, in which there's no experimental manipulation that's happening to them. And then after however length of time you decide is necessary for this work, this could be a week, this could be a day, this could be months. I've seen it all over the board before. Then after whatever the designated time period is, you have them go through the treatment. And the treatment is your actual treatment of interest, in which you can see how they did after the treatment. So instead of comparing a treatment and control group with each other, you're comparing participants with themselves, actually, in which they compare how they did in the treatment as compared to the pre-treatment before. The final experimental design we'll be talking about is mixed designs, and which is it's a utilization of both between and within group designs. This is an ideal experiment, but really hard to pull off. So again, just looking at our image, we get all the detail we need from looking at this. We have our participants, which is our sample from our population of interest. We randomly assign right here, but both groups go through a pre-treatment, which is a pre-designated amount of time in which nothing happens to these individuals so that they can serve as their own control group. However, afterwards, because we randomly assigned earlier, half of the participants, or whatever percentage ended up being randomly assigned, ends up in either the treatment condition or the control condition. So really, there's one part of this mixed design that's interesting, because there's one group that's going to be having a pre-treatment and a control aspect of it. Well, really, they experience nothing at all, but there's another half of this group that's going to experience the pre-treatment, then the treatment aspect of the study design, in which they'll actually be able to be compared to themselves and compared to the control group as well. Now that you've learned the 3 different types of experimental study designs, we can talk about what makes each of these study designs good. The first thing we want to do in a good experiment is reduce observer bias and demand characteristics. Observer bias and demand characteristics is this idea where we have certain expectations of our participants based on the group that they're in. So keep in mind, so for example, if an individual is in an experimental group, the observer or experimenter might treat the person in the treatment group different than an individual in the control group. And so the way that we get around this is by having double-blind studies. Double-blind studies are where neither the participant nor the researcher know who is in the treatment or control group. This works the best with medical treatment designs, in which we can have some sort of pill and placebo. You give them a kind of either the red pill or the blue pill kind of thing, where the red pill is a pill that actually has the dosage or medication that you want to give someone, and the blue pill has something that is not really there. However, the experimenter doesn't know which one they're giving the participant, and the participant doesn't know what they're receiving either. Therefore, a placebo is a great way to have a double-blind study in which neither the participant nor the researcher knows what's going on in the study and who's in the treatment or the control group. Additionally, we can have manipulation checks, in which we have some sort of aspect of the study where we check, did this manipulation actually happen? Did the people in the treatment group actually receive the treatment, and was it different than that of the control group? These can be done. There's a lot of different ways to do this. We can't really dive too deep into detail as to what all these manipulation checks are, but there are a lot of them. But essentially what they do is checking, does the treatment group actually receive the treatment, and was it different than the control group? So there's some reasons why internal validity is so high in experiments. The reasons are, one, you have random assignment with your between treatment groups, and additionally you have a manipulated variable, and you have controlling for confounds. However, there are still threats to internal validity that we need to notice here, and they're not any different than that in correlational research either. Those are construct validity, measures of internal reliability, all of your reliability and validity checks that were a problem before in correlational research still exist in experimental research. So you're never out of the woods to reduce your bias completely. However, it's good to know that we are still manipulating our variable, and we can still say that we have aspects of causation that are associated with our experimental study. However, external validity might be low. That's because, as compared to correlational studies, normally we have smaller sample sizes and it's harder to actually recruit participants for experimental studies. Additionally, lab experiments don't always translate to real world. If somebody is in a lab, there's so many other variables and confounding variables that exist within the real world that we're not able to really generalize towards the real world. So, something to keep in mind, although they have very high internal validity and we're often able to say our independent variable caused our dependent variable, it's very possible that we have low external validity with an experimental study. So, even though you had all the great sampling procedures, everything was great about that, the fact that you're running it in a lab and this isn't a real world kind of scenario gives you low generalizability towards these other populations of interest. Next, we'll talk about quasi-experimental research, which is a unique aspect of experimental research in which we can't truly manipulate our independent variables, but we use these grouping variables still in a way that mimics an experimental research. So, what is quasi-experimental research? Quasi-experimental research is when an experimenter does not have full experimental control of the variables. For example, let's take this as an example. A researcher is interested in examining the differences between genders, but the problem is we can't randomly assign gender. So we're forced to do a quasi-experimental study and assign participants in groups by gender. So our groups are no longer condition 1, condition 2. Our groups are male and female in this scenario here. You can also do it by race and ethnicity. You can also do it by age groups. It's when we have some sort of grouping variable or categorical variable that's a nominal variable that we're able to group people by in our quote-unquote experimental design, otherwise known as a quasi-experimental design. So really what we need to look at is what is the differences between a true experiment and a quasi-experiment. And the way that I like to do this is I like to talk about it in terms of this. I thought this was a really great graphic. So you start to talk about, are participants randomly assigned? You say, yes, it's a true experiment. No, then you ask yourself, is there control for a comparison group or multiple measures? So that's kind of that within subject study design where you say, oh no, there isn't that. Then we have a pre-experiment, which is essentially a correlational study of some sort. If we do have that, if there is a comparison group of some sort, we have a quasi-experiment. You might really be asking yourself, why would we ever really even use a quasi-experiment as compared to an experimental study? And the truth and reality of it is because it's practical. And there are often times when we can't even do a true experiment. For example, we can't just randomly assign things. For example, things like sex, eye color, handedness, we can't randomly assign those. Those are attributes that people already have. Whereas conditions and so forth, we can randomly assign individuals to. So because of that, we simply assign our groups based on these uncontrollable factors. Another aspect is ethics. So imagine we're interested in studying child abuse. Well, it wouldn't be too ethically to randomly assign parents to abuse their children for the sake of our study. Therefore, instead of randomly assigning students or participants or children to this abuse condition, what we do is we find children that have been abused in the past and assign them to the abused group and have some sort of control group that compares the two with them. So keeping in mind that because there's some sort of experimental or control group or comparison group we're able to see the true difference between the two and compare them, excuse me, like an experimental study. However, we're not randomly assigning them. We're not doing anything associated with that. So that's really the main reason we use quasi-experiments, is because it's overall just practical. So one concern with quasi-experiments is that because we have this lack of random assignment and this idea of history threat, which is essentially that somebody who contained this attribute might have a different history as compared to those individuals that don't have that attribute, and if somebody were to actually be randomly assigned to that attribute, take for example the individuals that are child abused, that have been abused as children, oftentimes have a different history as compared to their control group counterparts, where we can't control for that when we're doing a random assignment. But these are both threats to our internal validity. So essentially what I'm trying to say is that we have less internal validity than a true experimental study, but we probably, depending on how well the experiment was run, have better internal validity than their correlational studies in a quasi-experimental design. So, in summary, this is a shorter lecture for y'all on this Monday afternoon. An experiment is a study where a researcher has manipulated at least one variable and measured another, as compared to its correlational counterpart where both variables are measured. In an experimental research, it's possible to infer causation if it's done correctly. So that's what the true power of. But keep in mind that your external validity is a little bit lower. Additionally, there are three main types of experimental designs. There's that between subjects, where we're able to randomly assign subjects to groups. The within subjects design, where participants serve as their own controls. And then the mixed design, which is a blending of the between and within subject designs. Additionally, experiments have high internal validity but often have lower external validity, and that's oftentimes because there's lower sample sizes associated with experiments, and additionally those lab component settings. It is very possible for experiments to be run out in the real world, but they're very unlikely and don't happen very often. But that is the ideal situation where an experiment is run in a real world setting so that we can have both high internal validity and high external validity. Although it's not seen as common in practice, it is very possible and it does exist out there. And lastly, quasi-experiments lack that random assignment aspect where we assign people based on some sort of pre-existing characteristic in our study.